Hello everybody and welcome back to our Game Engines class. In this lecture series and in this unit, we will be talking about the animation models in Ogre 3D, and we will learn about, or rather focus on animations and how they work in general. And then in particular, we'll look at how animation is done in 3D, in Ogre 3D specifically. So far, what we have created in our class have been practically static and lifeless. We did use the user interaction models in the last lecture unit, and we covered how you can actually use frame listeners and observers in general, or the observer pattern in general, to be able to communicate with your operating system as far as your input readings are concerned from mouse, from keyboards, from joysticks, and things like that, and then incorporate these into your 3D application. And we moved the Sinbad mesh around, but the Sinbad was in T-bow pose, and it was just going statically. It was dynamic, but it didn't have any animation associated with it. So what we're going to do in this lecture and in the labs that we will see in the next couple of videos, lectures, how you can play an animation in Ogre, and then the concepts that are relevant to the animation and the animating of objects in Ogre, how you can combine two animations at the same time. Ogre actually gives us a pretty nice mechanism to do that, and then how you can attach entities to your animations. For example, for the Sinbad, to be able to draw a sword, which is basically a different entity that you can use in your scene and as a part of the animation. Ogre provides a very simple and flexible animation system that will allow us to script animation for several different types of purposes. We can use skeletal animation, basically utilize a mesh that is also has an animation system attached to it, created for it, and then this way we can animate the mesh using a skeletal structure that determines how the mesh deforms. We'll talk about it next. You also have vertex animation. Basically, you can animate a mesh by using snapshots of vertex data and then determine how the shape of the mesh will change, kind of like morphing animations. You can also use scene node animation, basically animating your scene nodes automatically to create effects like sweeping your cameras or making objects follow a predefined path and things of that nature. So far, when we used WASD to move our mesh, we kind of utilized the scene node animation in a limited sense, effectively. And you can also use numeric value animations, basically using your Ogre's extensible class structure to animate any value, for that matter, that you are interested in. Now let's take a look at skeletal animation and see what it is and how it is done. Skeletal animation basically is the process of animating your mesh by moving a set of hierarchical bones within the mesh, and then these in turn will move the vertices of the mesh according to the bone assignments that are created and stored in each of your vertices. An alternative term for this approach is basically called skinning. And so if you've taken the advanced animation class or any basic 3D animation class, you will have learned about skeletal animation. You basically create a mesh, you create a bone system for this mesh, and then you skin the mesh, effectively assigning for each of your vertices effectively a weight based relationship between the vertex and the bone. So when you have the bone move, then the vertices that are attached to it or skinned to it, they will move with it. And if you have a weight-based system created for vertices, so if a vertex is controlled by two bones, then when each of those two bones move, a combinations of their movements will control how the vertex moves itself. The usual way of creating these animations are usually done through modeling tools, such as Blender, 3D Mesh, 3ds Studio, 3ds Max, or Maya, or any other 3D modeling software that you use. Ogre provides us exporters that we can use. And so if you wanted to create a 3D model in, let's say, Maya or 3ds Max or Blender, you'll use exporters that would allow you to take these models and then use them and create them in the format that Ogre as our engine will be able to utilize. You may be able to go on the website that I have listed at the bottom of this page, and there's a link to exporters that you could actually go to and see the kinds of exporters that are there and which one is comfortable and you can use. There are many different grades of skeletal animation, and not all engines or 3D modeling software will support, for that matter. But Ogre practically supports the following features as far as our skeletal animation is concerned. Each mesh can be linked to a single skeleton. So basically, we will have a one-to-one mapping between the mesh and the skeleton that can control it. We may have unlimited number of bones per skeleton, so you can have a skeleton with very, very large number of bones associated with it. There are hierarchical forward kinematics on bones supported by Ogre, and usually we refer to these kinds of system an FK. You can have multiple named animations per skeleton. So, for example, you can have a skeleton that may have a walk animation, a run animation, a jump animation, a shoot animation, a swim animation, a crawl animation, and all those sorts of things. There are unlimited keyframes per animation that can be assigned, which would allow us with basically utilizing motion capture animation that have a large number of keyframes, and we can still use those animations in our system. You may be able to use linear or spline-based interpolations between keyframes in your animations. You can have a vertex assigned to multiple bones and then assign to each vertex and bone a relative weight for supporting smoother skinning for our objects. We may also have multiple animations that can be applied to a mesh at the same time, again using the blended weighing. And so this way, you may be able to actually have, like, for example, a blending between a run and a crouch, for example. Skeletons and the animations that go into them will be stored usually in a .skeleton file. And these .skeleton files are produced by the Ogre exporters that I talked about in the last slide, and you can find online. These files are loaded automatically when you create an entity based on a mesh that is linked to a skeleton in question. So from that point on, you can use an animation state to set and use the animations for your entity, and then to be able to perform all sorts of skeletal animation with your object. Skeletal animations can be performed both in hardware and in software. In terms of implementing your animation in software, which is the scope that we cover here, you basically do that at the application level, and then you set your animation state and work with it. If you were interested in doing the hardware animation, or rather using your shaders to outsource your animation and send it out, instead of doing on GPU, send it out to your CPU, send it out to your GPU and your graphics card to do. It also basically means that the vertex data that does not need to be loaded, or rather be reloaded every time that you use it. And so it's much more efficient and quite preferred to be able to do it that way. However, you would have to actually go and do your skeletal animation in vertex programs, which is a little bit advanced for us, and we will not be covering this concept in this particular lecture unit, and in particular in this class. Let's take a look at animation state and see what it is and how we can use it, and then we'll go to the code and we'll implement these animations, or rather a skeletal animation for our Sinbad object that we created last week. So when an entity that contains an animation of any type is created, your Ogre system will be giving this entity an animation state object per animation to allow you to specify the animation state of a single that entity. You can animate multiple entities using the same animation definitions, and Ogre basically sorts through them internally to use the animation states. The way that we can use an animation state is basically we'll retrieve a pointer to the animation state object by calling the entity get animation state, and that loads up the pointer to our animation states for the entity, and then we'll be able to call the animation states methods on this return object to update our animation. Or even in the frame started event. Each animation state needs to be enabled before we're able to utilize it, and we can use the set enabled method for our animation states to have it take place, or rather take effect. We can also both set the weight of the animation and the time position of our animation state, whichever we feel appropriate to implement the effects and the animations that we want to use. Animation state also has a very simple add time method that we can use to alter the position of our animation incrementally. And it will also automatically loop for us. We can also give negative values to our add time, or positive values to the add time to set our animation forward, or to set our animation in reverse order or backwards. So this is basically all the concepts so far to get us started. And so without further ado, let's go to the code and let's try to make the Sinbad animated. Okay, before we go and start talking about implementing our animation, our code here, let me just go over we're not going to be building this content of this unit in this video lecture from scratch. We have already implemented our frame listener from the previous lecture unit that we discussed previously. And if you haven't really watched those videos, I highly recommend you to go ahead and watch the video lectures, the playlist for Unit 7 that discusses the input-output interactions and mechanisms with Ogre 3D, and that part, those videos are quite essential in establishing our frame listeners so that we could actually interact with the game. And since animation itself is an interactive sort of mechanism, it's a dynamic mechanism, we would have to implement a lot of those functionalities within our frame listener. So if you haven't watched those videos, please go ahead and watch those and build your application from there. That application from Unit 7 that we discussed for frame listeners and input-output interactions and the input system basically covers this code that we will be working with. So what we did previously was to create our frame listeners class. And the frame listener class that I created, I called it my frame listener, and it's basically inheriting from the frame listener class that is from base application and example application. The member variables within our frame listener that we had already established are our camera, our node, which is basically a member variable for the scene node, that contained the object that we interacted with. We created a speed so that we could move the object at a certain speed, a timer that would help us establish a mechanism so that we could efficiently communicate the amount, or rather the key presses, to our system. And then we established our input-output interaction and the input system. We created a parameter list, a window handler, and a stringified window handler. And then we created an input manager, a keyboard, and a mouse. And then the implementation went ahead and used this functionality in our frame started to capture the keyboard and capture the mouse, and then control the object with the keyboards W, A, S, and D, left shift and right shift to speed up and slow down our object. And with the mouse, we utilized the movement left and right and up and down of the mouse to rotate our camera view and get that kind of control over our system. So what we are going to do to this frame listener and the application that we have is that we are going to create two member variables, one for the entity that will pass from the parent application, and then one pointer for the animation state. And we will then go ahead and update the frame listener constructor so that we will be able to actually pass these variables to it. And then once those are created, we are going to actually use the animation state to get certain animation states from our entity, and then to establish our skeletal animation and to work on it. So so what we're going to have to do is go here and in our frame listener class, create two pointers, one for an entity pointer that will be the object we are going to animate, and then one for an animation state pointer that will be the animation state on the object that is going to be animated. So we first create an entity pointer. Let's call this ENT or underscore ENT, just to stay true to the way that or the convention that I used from the previous unit. And then an animation state pointer, and I call it anim state. So these are the two member variables that I need, a pointer to the entity that will be animated and a pointer to the animation state that we will use for to animate this entity. Then we'll have to modify our frame listener's constructor to get these pointers to be passed to it so that we could actually utilize them in the frame listener. So the constructor from the previous unit that we talked about, we passed a scene node. We passed the M window, which is a render window pointer, so that we could actually interact and get our input from keyboard and mouse from our operating system. And then we will be passing an entity pointer, ENT. Okay. So then what I'm going to do is I'm going to go ahead and establish my entity, my member variable, to the entity that is passed to it, practically similar to what we did with our camera and scene node. We're basically going to make the entity, our member variable entity, to be pointing to the entity that was passed to our object so that we could actually utilize it. And then what we're going to do is to read. So, and then what we're going to do is to read the animation state from the entity that we passed. And so for this particular example, I'm going to use the dance animation. And I'm going to show you how you can actually see what kind of animations there are in the entity. But one of the animations is called dance. So I'm going to set the anim state to be effectively get animation state dance from my entity. What this is going to do is that it's going to make the anim state member variable that I have to point to the animation state of the entity that effectively is a dance animation. Then we use the anim state set enabled to true. And also, I want this animation to run indefinitely. So I'll make this anim state set loop to be also true. So what this does, add the constructor for my frame listener when it is created, it's going to pass an entity from the parent application that is constructing an instance of this frame listener. And what I'm going to do is that I'm setting the member variable entity underscore entity of my frame listener to be the same as the entity that is passed to it by the parent application. Then I'm going to set my anim state to be the dance animation, and I'm going to set the anim state to be enabled, and set the anim state to be looping. So this will set my animation up to be playing, and then in order to play my animation, all I need to do is just to go to my frame started function, frame started method of my frame listener, and just simply add time to the animation. And if you noticed from the last week's video, what is happening with the frame starter is that frame started happens, or rather is called, it's basically within your frame listener. So it is called to be updated every time your renderer is ready to start rendering on the screen, on the window. So every time the frame is starting, basically we capture the keyboard, we capture the mouse, and then we implement the logic for our keyboard interactions, for the mouse interactions, and all those sorts of things. We do the same thing with our animation. Every time the frame is going to run, we are going to effectively add time to our animation, and then the back end of our engine, the animation engine, will basically read the animation state and then perform all the movements of the skeletal bones on our animation, and then set it to be rendered. So all I need to do in my frame listener then, the frame started member method of my frame listener, is to set my anim state to add time to it, and then the amount of time that I will add to it is going to be equal to the amount of time that was spent or passed since the last time the frame started occurred. So it would be EVT, which is my event member variable, and time since last frame. So effectively what this does is it's going to update my animation state timing to basically move it to the time that has passed since the last time, or the last frame started event occurred. So every time frame started happens, we are going to look to see how much time has elapsed since the last rendering up until now, and then we're going to update our animations with that exact same amount of time. One last thing that we need to take care of is in our original application, my interactive example application that I have created previously, I would have to go and set up my frame listener, which is here. So when I create my frame listener, so I already have in my base application, or in the parent application that called the frame listener, I created my listener object that is an instance of my frame listener class that I created, and I'm passing to it a scene node, a window, and a camera, and I'm going to have to also pass to it the entity that I want to animate. Simply, the entity is basically the Sinbad, and if I have it, let me see actually. From last time, where did we create the entity? Yeah, so the entity is basically the Sinbad, right? We created the entity Sinbad based off of the Sinbad.mesh. So I'm going to have to pass the Sinbad. You know, I see why the issue here that I don't have access to is that the Sinbad entity that I'm creating is a local pointer. So I'm going to have to actually move this up as a private member variable. So let's make this an entity pointer. Let's call it Sinbad. And then make Sinbad as an entity. And then we are going to pass the Sinbad to this function. So I simply just moved the entity pointer from the create scene function. I just moved it up as a member variable up in my private member variables, and I'm passing that entity, which already is created in the create scene from last time, and I'm passing that into my frame listener. So let's run the code and see what we see. If I don't have any errors in my code, and I've done everything correctly, what you should be seeing is that now the Sinbad should be dancing as soon as the scene starts rendering. And here we are. So the dance is basically an animation that we have in our skeletal mesh, and basically makes the Sinbad to kind of do this silly dance here. And all we needed to do to enable our dance mode was basically for our frame listener pass this entity pointer to the frame listener so that we would have access to it. And then in the frame listener frame started method, I created the or assigned my animation state to the dance animation, and then I enabled it and I set it to looping, and then in the frame started, actually in the constructor of my animation, I created the entity and I set it up. Then in the frame started method, I established my animation to be to look at the time since last frame and then run the animation. So let's go ahead to our constructor and set our animation state to not loop. So if we do set looping false and we run this code, then the Sinbad will dance once and will stop dancing. And there we are. So before we actually move on to the next video and discuss a little bit more details about how the animation states can be added, how you can actually have multiple animations on your skeletal mesh, I went back and set the looping of my animation state to be true, and I want the animation to stop. And now I want to show you how you can slow down or speed up your animation. Let's say that we wanted to make the animation to run as a kind of slow motion, kind of like at a quarter of the speed that it is. In order to do that, we are going to go to the add time method of our animation state from the frame started function. And in there, we will basically multiply the add time from the time that was passed to it since last frame. Then we're going to multiply it by a quarter, 0.25%. This effectively slows down our animation by 1/4 of its actual speed. So it's going to show as if the Sinbad was doing a slow motion dance. So let's compile and run this application and see what happens with this. Now the Sinbad should be moving at a much slower rate. And as you see, this Sinbad is now doing his silly dance, but at slow motion, very, very slowly. So let's go ahead and do this and speed it up. Have the Sinbad to do a really, really quick dance. Now, in order to do that, we're going to multiply this, let's say, by the factor of 5. Compile and run. And so now my Sinbad is doing really, really a crazy dance, and it's doing it very, very fast. And so this is a really nice little overview of animation states and basic skeletal animation in Ogre. I think I'm going to make this a standalone video, and so this will be our first video in the playlist for animation. And I'm going to close this video up here. And in the next video, we are going to discuss how you can add multiple animations to your mesh an entity, and also looking at how you can basically combining your user control with the animation to make the Sinbad practically walk. So right now, when we do WASD, Sinbad just doesn't walk. Is doing the silly dance on a looping pattern, and there's nothing really interactive here with the animation. So we're going to basically combine the user control with animation and make it a little bit more interesting. So I will see you in the next video.